Hello, we are EpiCool. We have designed an implantable device that will control focal neocortical epileptic seizures using focal cooling. The device is in two parts, a box in the brain and a box in the body. The box in the brain consists of a neural electrode which will read neural activity, a thermistor which will tell how cold the brain is, and a filtering circuit which will filter the input from the neural electrode. In the body box, we have a PCB which will control all of the signals, the tiny which will control the PCB, and a battery pack which will power the entire thing. This is the Peltier cooler which will reside in the brain box and provide the cooling to the brain. This is the user interface. It is controlled by the Arduino interface. If you click on the serial monitor here, this allows you to send out simple messages to the tiny. And you can see it spit out the Y character with a couple of dots on top. That means that the tiny is ready to receive your message. So you can type any character here at all, and the tiny will switch into USB mode, which means it'll be listening for commands from the PC, and it won't be able to cool at this point. So you have some options to be able to tell it what to do. If you type a G and send it, then it sends all of the data that it has collected. And it has sent a message here acknowledging that. If you type an S and then another character, any of the parameters that you might want to set, say the amount of time you want to cool for, and then the value of that, and hit enter, then it sends a message that says it has changed that parameter. If you're ready to activate cooling, then you can hit the A key, and it will start sending you its data.
So this is our Peltier device here. Attached to a small PCB. The device is white here, which is also touching a heat pipe, which is this long rod here. And to look at some of the data, please direct your attention to the screen where we have a live feed of data because we have thermistors that are actively monitoring the temperature information obtained through the Peltier device.
So our device will detect neural signals via the electrode, and the electrode will feed its electrical signals into our neural input circuit, which is in the brain box, which will then amplify and filter the signal and send that to the tiny Arduino. At the same time, we will have our temperature circuit recording temperature, and that will also send its information to the tiny Arduino, which will detect whether or not a seizure is occurring via the algorithm, and then it will tell the current driver, which is controlling our Peltier cooler, whether or not to turn on, and the current driver is actually underneath the PCB circuit here. And then, so if a seizure is occurring, the current driver will drive the Peltier, and the Peltier will cool the brain, essentially stopping the seizure.
Now that our circuit has been all hooked up and our thermistor is attached to the output, let's take a look at this waveform chart that demonstrates the live cooling cycle.
Okay, cooling is being activated.
Tired of wires.
Okay, activation begin. So as you can see, the cold side has drastically decreased in temperature, while the hot side, the graph on the bottom, is continuing to increase, which is as expected.
Because our microcontroller is so small, it doesn't have very much room on board for storage. So before we can store more than a couple of cycles on the microcontroller for transfer to the computer, we're going to need to install the micro SD card, which will be coming in a few days and be built into the finished product eventually.
Hi, we're EpiCool.
And we are going to EpiCool your brain today.